An electromagnetic wave has a wavelength that is about the size of the diameter of an atom. What region of the electromagnetic spectrum does the wave belong to? Let's consider an electromagnetic spectrum in terms of lambda, and visible light it's about 450 or something like that, but nanometers, nano it's what it's times 10 to the power of -9, and it's about 5 times 10 to -7 in meters, and red about 700 nanometers. Then ultra, it's visible, ultraviolet, and then X-ray, and then gamma. And X-ray it's about 1 nanometer or 0.1 nanometer, so it's actually what, 10 to -9 or 10 to -10 meters and less. And gamma it's about 10 to -12 meters or less. And here it's given that wavelength is about diameter of an atom. Diameter of an atom it's about 10 to -10. Diameter of nucleus it's 10 to -15. So it's 10 to -10. So definitely it's not infrared, because it's greater than visible. Not visible, because it's 10 to -7. And definitely it's not ultraviolet, it's X-ray. The next diagram 1 shows the variation with position of the displacement of a standing wave formed on a string. Diagram 2 shows the variation with position of the displacement of traveling wave. What is the phase difference of P and Q, and the phase difference of R and S? So it's standing, it's traveling. And if we consider standing, all particles within 2 consecutive nodes, it's also a node, are moving synchronously. It's called in phase, and all these particles are moving down. Actually, we can say up and down, or to the right, to the left, and all particles here are moving synchronously up. So all particles for standing can be either in phase or anti-phase. So all these particles within 2 consecutive nodes are in phase, but if we consider particle here and particle here, they will be in anti-phase, or phase difference is pi or 180 degrees. So phase difference for P and Q is 0. And for traveling, definitely they are not in phase, and actually we can say pi over 2 directly, and it's C. But let's consider in more detail. For traveling, for example, for standing, a bit later it will be like this, and moving, so it's these particles moving down, this up, and so on. But for traveling, a bit later, this wave will be like this, and you can see that R is moving up, S is moving down. But how to find the phase difference? And if we compare standing and traveling, for standing, particles have different amplitudes, but for traveling, all particles have the same amplitude. And how to find phase difference for R and S? And you can see that it's one wavelength, and there are 8 1 2 3 4 yes, there are 8 8 squares. So 8 squares, it's like 1 lambda, and 1 lambda corresponds to 2 pi or 360 in degrees, like one complete revolution for trigonometric function, something like that. And distance between R and S, it's in terms of lambda, is what? It's 2 squares. So 2 squares, and 2 squares is x, and from such a proportion we can find x, and x is the required phase difference. So it's what, 2 times 2 pi over 8, and you can see it's pi over 2. Or phase difference, it's like shift of particles in terms of lambda and multiplied by 2 pi. So it's shift 2 squares over 8 squares, it's lambda, and multiplied by 2 pi, or like this, it's delta lambda over lambda and multiplied by 2 pi, or 360 degrees. It's pi over 2, so it's C. And that's all for this question.